All right, so first, as a reminder that the sine of an angle measure, an acute angle specifically in a right triangle, is equal to the ratio of the opposite side length to the hypotenuse. So we wrote it something like, in class we wrote it something I'm going to put at the very top. The sine of an angle measure is equal to the opposite over hypotenuse. Now remember that this symbol right here does mean it's theta. It represents an angle measure, one of the acute angles in a right triangle. So don't think that's a zero. That is what we call theta. It's a Greek letter, and it's used to represent angles in math. All right, and then we have the cosine of an acute angle in a right triangle is equal to the ratio of the adjacent to the hypotenuse. And then lastly, the tangent of an acute angle in a right triangle is equal to the length of the opposite to the adjacent. So those are the three trig functions that we're going to be using throughout this whole sheet. I'm going to finish writing them out at the top there. So we have sine of theta at the top. We have cosine. Remember, theta just represents the angle measure, or the degree, which is adjacent over hypotenuse. And then tangent, I'm going to put on the other side. The tangent of theta is equal to the opposite over the adjacent. All right, so in the next section, numbers 4 and 5, they just want us to use the calculator to figure out what these equal here. So cosine of 31, you simply put in your calculator cosine of 31. Remember, you do need to have some type of scientific calculator where you can just put that in. And you want to make sure your calculator is on degree. If it is not on degree, then you will get an answer in radians, which is not what you want and is not what is expected. So make sure your answer is in, or your calculator is in degree, which I stressed in class, so make sure you know how to do that. So if you put in cosine of 31 in your calculator, you should get 0.85. If we round to the nearest thousandths, that's going to be 3 decimal places out. So 857. Now behind the 7 is a 1. And remember, I said thousands is 3 decimal places out. So technically in your answer, you want the first 3 decimal places. The number behind that determines if that one stays the same or if it rounds up. So remember, 5 or more round up. Otherwise, you leave it alone. And we're going to leave that alone. So I'm just going to erase the 1. Ooh, that is erasing a lot. Let's go ahead and fix that. Now it's not in blue, but it's okay. We're going to fix it. There we go. All right, so 0.857. So you're simply just typing these in the calculator. Remember, you can only mess these up if you don't have your calculator in the right setting or if you're not hitting it incorrectly, so use a good calculator. For the next one, notice this here is the inverse tangent. So that's tan inverse. Usually on most scientific calculators, you have to hit second and then tan, and it'll change to tan inverse function. Or if you have a 36X Pro, you can just hit tan twice, and it'll change to inverse tan. And you should see that you get an answer 89.204 if we're rounding to the nearest thousandths. And whenever you use an inverse trig function, you are finding the angle measure. So that is a degree. So 89.204 degrees. All right, then moving right along to the next section of set of instructions there tell us we're going to write the equivalent expression using co-functions. So co-functions, remember that this here is kind of showing us what we mean by that. So the sine of some angle measure is equal to the cosine of that angle measure subtracted from 90. So if it says sine, we're going to put cosine. And if it says 63, well, we're going to get the number that goes here by just doing 90 minus 63. And you'll see that's 27, so really we should just have cosine of 27. You do not actually find the answer in the calculator, you're just writing the equivalent expression as a cofunction or using cofunctions. So same thing here, if we have sine, the cofunction is cosine. And if it's 59, we're going to subtract from 90, and we get 31 degrees. So that's it. You don't have to actually calculate it. You just use the cofunctions. And remember that the cofunctions are just cosine. If it's cosine, you're going to put sine. If it's sine, you're going to put cosine. And remember, to get the number, you just subtract from 90. All right, so in the next section here, it's asking to find the sine of b, the cosine of b, and the tangent of b. So they all have the same angle of focus. So our angle of focus is angle B. So in the triangle, I'm marking angle B. That is our angle of focus. Remember, it does matter how you label your triangle depending on the angle you're using. So that's why it's very important we note that we're using angle B. But first things first, we always identify our hypotenuse because that is always across from the right angle. And then next we have our opposite side. Well, if you start at the angle that we're focusing on, our opposite side is across from it. And then that leaves this third side to be adjacent. Just as we showed in the top there, that the sine of b, so the sine of an angle, is opposite over hypotenuse. So at the very top, we have opposite over hypotenuse. So you're just going to write whatever's on the opposite side over whatever's on the hypotenuse side. So that is going to be those two sides, but we have to put in the right order. So 8 over 17, or 8 divided by 17, or 8 to 17. Now, you simplify if possible, excuse me, and it cannot be simplified, so you're just going to leave it as is. So the next one, cosine of b, I'm going to erase a little bit here and here. Oof, got a lot of markings, so I'm just going to have to mark that over again. So as we had our hypotenuse, so our angle b, our opposite, and then our adjacent. So cosine is adjacent over hypotenuse. So we just need the fraction for the adjacent, which is 15, over the hypotenuse, which is 17. So 15 over 17. And then once again, this does not simplify. 17 is a prime number, so nothing goes into it besides 1 in itself. And then last we have tangent. Tangent, as we see at the very top on the right side, is O over A. So we're just doing the opposite length over the adjacent length. So if you look at your triangle there, the opposite is 8, the adjacent is 15. So it's just 8 over 15. Once again, does not simplify, so we leave it as is. So yeah, just make sure you label the triangle correctly to get these right. You did not have to solve anywhere, you just had to find the sine, cosine, and tangent of that angle. So you did not need to solve. Alright, moving right along. So now we're getting into the solving portion. Now it actually says solve, so we do need to solve. Now we have 4 different scenarios on what we could have in these triangles, and we have to know what to use when. So in class we talked about the 4 different scenarios, and the first thing you want to identify is what you want to find. Are you finding a side? So do you want a side length? Want a side length? Or are we looking for an angle measure? Or an angle measure. So notice the first 2 bullet points deal with if you want a side length. The second 2 bullet points deal with if you want an angle. So you have to first identify what you want. And then, depending on what you want, you have to then see what you know, and then I'll tell you how to solve it, basically. So if you're looking for a side length and you know 2 sides, then you use the Pythagorean theorem. If you're looking for a side length and we know 1 side and an angle measure, we use the trig ratios. If you're looking for an angle measure, could be either of these 2. So if you're looking for an angle and you know 2 angle measures, then you're going to add those 2 and subtract from 180 to get the third one. If you want an angle measure and you know 2 side lengths, then you're going to use inverse trig. So if we go back to number 11 here, and you see what we have. So we have, we're finding AB. Notice AB is a side. So we're looking for this. I'm going to put an X there because remember, if we have unknown information, we can use a variable. Now we have 2 side lengths. We're looking for a side and we know 2 side lengths. So just going back to our little decision guide, we're looking for a side length and we know 2 sides. So we're going to use Pythagorean theorem. So if we go back here to number 11, remember that Pythagorean theorem is a squared plus b squared equals c squared. Remember, C absolutely has to be the hypotenuse. That has to be the hypotenuse. The other two are interchangeable. I mean, you could put A here, B here. It doesn't really matter which one's which because you're adding. So in all reality, you just got to make sure that C is on the equal to side, which is your hypotenuse, should be on the equal to side. So remember, you find your hypotenuse by drawing an arrow across from the right angle. So hopefully you see there that X is our actual hypotenuse. So that is going to go in for C squared, or for C. And then A and B are just the other two. Once again, it doesn't really matter the order because you're going to end up adding, and adding you can do in either order. So you do want to first figure out what this equals. So you want to do 7.7 squared and then 14 squared, add them together. Or if you have a good scientific calculator, you can just put it all in there together with the squares on it, and you will get, so 255.29 equals x squared, because I'm just bringing down the x squared. Now remember, to get rid of the squared here, you have to take the square root. That way those invert each other. But since we take the square root on one side, you got to take it on the other. And then you'll get that x is equal to approximately 15.97779. So we're going to go ahead and round, and we're going to do 15.98. So, and that's approximately, so I'm going to change that to my little approximately equal sign, or squiggly. Alright, so about 15.98. And remember, make sure your answer makes sense. I mean, this is the hypotenuse, so it should be the longest length. So you should expect something bigger than both of these answers. And that's one way you can at least use process of elimination on a multiple choice test. Alright, so now for the next one, it is asking us to find x. So once again, identify what that is. In this case, it is a side length. So we're looking for a side. And also look to see what we have. We have an angle, we have a side length. We don't know this side length. Even though there's a y sitting here, we don't know that length, but we do know one side length and we know an angle measure. So if I go back to my little decision guide, we want a length, a side length. We don't know two sides, we only know one. In this case, we do know one side and an angle. We do know one side and an angle, so we're going to use our trig functions. So remember, to do that, you're going to label the triangle. Always label that hypotenuse from across from the right angle. You're going to mark your angle of focus, which is just 32 degrees. You're going to draw an arrow across, and that's your opposite. That leaves the leftover side as your adjacent. Now remember, you always identify what you want. So we want that x side, and what we have the length of 13, and those are the two, that basically have something on it that we're going to use. We don't need this. We don't need to find y, so we don't need that. So notice what should be staring at you is O and A. So going back to the top, O and A is tangent. So that means we have to use tangent to set it up. So I'm going to write it out as I saw it at the very top. It looked like this. So I'm just going to place everything in the right place. So tangent, remember theta, this symbol here just represents your angle measure. So that's where you're going to put the angle measure. So tangent of 32 degrees equals opposite length. Notice on the opposite side we have an x. So that should be x. And then our adjacent length is 13. So now we can go ahead and cross multiply. Remember, you can always make something a fraction by dividing it by 1. Now we have something we can actually cross with. So I'm going to do 1 times x, which is just 1x, which is the same thing as 1. And then 13 times tangent of 32. Remember, you want to put the 13 in front of the trig function. You don't want it to look like 32 times 13. You're doing 13 times the tangent of 32 degrees. Notice at this point, x is by itself. So technically, you just have to put this in the calculator, obviously correctly. You should be using a good scientific calculator or app. That's good. And once you put that in, you'll get approximately 8.12. So 8.12 should be our approximated answer there. So notice the flow. Identify what you're looking for, then identify your strategy. So in the next one, we are looking to find f. Once again, that is a side. So we're looking for a side, so I know it's going to be one of those top two bullets. I have an angle measure and I have a side length. I have an angle measure and I have a side, and I'm looking for a side. So going back to my little strategies here, I want the length of a side. I want the length of a side. What do I have? I know one side and an angle, so I'm going to use trig again. I'm going to use my trig functions. So once again, to use your trig functions, you should label your triangle. Hypotenuse, identify that first. Then your angle of focus, drawn across from it, is your opposite. And then, of course, that third side is the adjacent. Remember, identify what you have stuff on that you're going to actually use. We have something on our opposite side that we need to find, so that's our F. We have something on our hypotenuse that we could use, the number 7. So I don't need the adjacent side. I'm going to scratch it out so it's not looking at me. And remember, O and H, if we go to the top, is sine. Sine is O, and sine of the angle measure is equal to opposite over hypotenuse. So we are going to use sine. So once again, from the top, I'm just bringing it down. The sine of an angle measure is opposite of hypotenuse. So remember, theta is this symbol here, this Greek letter theta is just representing your angle measure. So we have sine of 25 degrees equals opposite length, which is F, over hypotenuse, which is 7. So once again, I could set this up to cross multiply. So now I'm going to multiply diagonally, which is F, because 1 times F is just F. And then remember, you're going to write this as 7 times the sine of 25, and then see what it actually equals, because F is by itself. So we don't have to do anything extra. Remember, these will always turn into either a 1-step equation or a 2-step. So far, both that we've seen, the minute we cross multiplied, X was by itself, so that's a 1-step. F was by itself here, so that's a 1-step. So now we're just going to put that in the calculator and see that we get approximately, it's not the draw pin, okay, so F is approximately 2.96. 2.96. We don't have units here, so it's just 2.96. Alright, so moving right along, we're finding the measure. Remember that M means measure, the measure of angle A. The measure of angle A. So I'm looking for angle A. So that's basically like my X. Once again, you're looking for an angle. An angle. So therefore, when we go to our decision guide over here, we want an angle. So if we want an angle, if we know 2 angle measures, we're going to add and then subtract from 180. If we want an angle and we know 2 sides, we're going to use trig. So going back to it, you could see that we know one side. I don't know either of these other 2, so we don't know 2 sides. I know one angle, but hold up, I know this other angle. We know that that means 90 degrees, so technically we do have 2 angles. So if we have 2 angles, like it says here, we know 2 angle measures, we're going to add them up and then subtract from 180. So I just need to add those angle measures up. Once again, this means 90 degrees. So I'm going to add those up, and that's going to give me 150, and then I'm going to subtract that from 180. And notice we get 30 degrees. So X is X equals 30 degrees. So remember, the reason why we can do that is because the angles inside of any triangle have to add up to 180 degrees. So that's why we add those 2 and subtract from 180 to get that this has to be 30. Or just think, if this is 150 together, this has to be 30 to make it 180. Alright, and then the next 4 solving ones. Once again, identify what we're looking for. We're looking for theta. Theta is inside of an angle. So I know I'm looking for this angle measure. So I'm looking for an angle measure. I have 13 on this side, 4 on this side, so I have 2 side lengths, and I want an angle. So if I want an angle, and we know 2 sides, we're going to use the trig inverse, or the inverse trig functions. So we can identify our first label. This is the most common triangle where students label incorrectly, or they just think, oh, I know this is my hypotenuse. No, it's not. Just because it's slanted doesn't make it a hypotenuse, and so many students think the hypotenuse will always be slanted. It could be laying on its hypotenuse, like in this case, because remember, anytime you have your right angle mark, you just go across from it, and that's your hypotenuse. All right, and then across from the angle of interest is our opposite, and then our adjacent's the leftover side. So now once again we're identifying what we're using. So we're using that because it has a 4 on it. We're using this because it has a 13 on it. So we don't need this side because it has nothing on it. So O and A, just like the problem we saw before with O and A, is tangent. So remember, we're going to use our strategy is tangent inverse, trig inverse functions. So now you just make the fraction for tangent. Tangent is O, which is 4, over A, which is 13. So O over A is 4 over 13. And you just put that in the calculator. Anytime you're finding an angle using trig inverse functions, tan inverse, cosine inverse, sine inverse, you just type it in and see what you get. And we get approximately 17.1 degrees. So our angle theta is approximately 17.1 degrees. I feel like I'm making that degree symbol worse and worse. There we go. All right, now I gotta make my one look like that. Okay, so that is for number 15. So we're looking for an angle. We used inverse trig when we know two sides. Next, number 16, we're looking for an angle. We know two sides, so it's actually very similar to this one where we knew we're looking for an angle. We knew two sides. So same story here. We're going to label the triangle. So we have our hypotenuse. We have our opposite. Remember, opposite's always coming from the angle of focus across. That is our opposite. That leaves this side up here as our adjacent. So remember, identify what you're using. I'm using this side with 13 on it. I'm using this side with the 40 on it. There's nothing on that adjacent side, so I don't need it. So hopefully O, didn't mean to do that, but hopefully O, opposite, and hypotenuse are popping out to you. O and H, as you can see, the only one that has O and H in it is sine. So remember, we're using inverse trig functions since we know two sides. The sine is opposite, which is 13, over hypotenuse, which is 40. So if you put that in, you will get approximately 18.97 degrees, because that is our angle P. All right. So both of those were very similar in the fact that we were looking for an angle measure and we knew two side lengths. So we used our inverse trig functions to get our angle measure. Now for the next one, notice we are looking for a side. So look to see what we're looking for. We're looking for x. We're looking for a side. We know two sides. So going to our little decision guide, we want the length of a side. So it's one of these two. But we know two sides. So it's this first strategy. So we're using the Pythagorean theorem. So remember, the Pythagorean theorem is a squared plus b squared equals c squared. Remember, c has to be your hypotenuse. Absolutely has to be your hypotenuse. So your hypotenuse in this case is 32 because it's across from the right angle. So that is going to be our c. And the other two, remember, it just really doesn't matter the order because you're going to end up adding, and you can add in either order. So I'm going to, so we have x squared. Now we have to square 17. So if you do 17 squared in your calculator, you should get 289. And then we have to square 32. Notice we're not just adding these together because they're across on the equal sign. They're across the equal sign. So you have to do them, just simplify as you go down here. So 32 squared is 1,024. So you actually need to go an extra step compared to the last Pythagorean theorem problem because you're looking for you're looking for one of the legs. So you have to get x by itself here. And when we do that, we get that x squared is equal to 735. But remember, once the x squared is by itself, you need to get rid of squared by taking the square root. And we get that x is approximately 27.1. Now remember, we were looking for a side length, so this is not a degree, it's an actual side length, so we can leave it like this since there's no units for length. Alright, so just to point out the difference again between this Pythagorean theorem problem and the first one here you were finding the hypotenuse. So your C was your x. So you were able to just add and square these things on one side. But in this one, you have your hypotenuse and you're looking for a leg. So when you square everything, they're on opposite sides of the equal sign. So you have to invert one of them to get over there to get your x squared by itself, and then you still take the square root in the end. Alright, so our last solving problem in this section, you notice here that we're looking for m, and m is a side length. So we're looking for a side, so we know we're dealing with one of these top two bullets here because we're looking for a side length. And then let's see what we have. So we have a side length and we have an angle measure. So we know one side length and an angle measure. So if we know one side length and an angle, we're going to use that trig. So remember, anytime you use trig, you want to go ahead and label your triangle. First with your hypotenuse, because that's the one across from your right angle. You want to identify that. And then your angle of focus, you take an arrow across from that. And remember, that's your opposite side, because it's opposite of the angle. And then remember, your adjacent is kind of like the third one left over. Then remember that you identify what you're using. So we need to find m. We have 43. So we're not using this side, so I don't care to even look at that O. So notice that's the A and the H. The A and the H. So going back to our beginning page, A and H. Notice up here at the top, it's cosine. So I'm just going to bring that over. The cosine of the angle measure is equal to the adjacent over hypotenuse. So we have cosine. Remember that this just means our angle measure, like our angle of focus, which is the theta symbol. So cosine of 85, because that's our angle of focus that we use to label, is adjacent, which is 43, over the hypotenuse, which is m. So here, when you set it up to cross multiply, hopefully you notice when you cross here, we get 43. When you cross the other way, you're going to end up multiplying m times a cosine of 85. Once again, you don't want to write it like that. Otherwise, it looks like you're just doing 85 times m. You want to write it to where the m is in front. So you always put whatever you're multiplying the trig function, with the number by, you put that in front. So m times the cosine of 85. So now hopefully you notice that m is not by itself on one side of the equal sign. It is over here with cosine of 85. So it's over here. So we need to get rid of cosine of 85, but notice it's multiplying, so the inverse would be to divide by that cosine of 85. That way it's gone, but if we did it on that side, we have to divide on this side by cosine of 85, which now, m will be by itself. We have to just put in the calculator 43 divided by cosine of 85, and that is 400. Ooh, I'm running out of room here. 409. I'm going to have to erase this. It's going to bother me. Let's fix that. Alright, so 493.4 equals m. So that is our answer for our m. Yes, it is large, but it is bigger than that side of 43, which is good. So we know it's not, it's something that could be the hypotenuse. Alright, so 493.4 is our m there. Alright, so now moving on to kind of like the more application problems or wordy problems, we can say, so we know we have a triangle CAT. Now remember, when you draw your triangles and you see all this criteria coming up, I would not go and label the letters for the triangle yet. I would just first create the triangle. Obviously notice we're going to have a 90-degree angle in there, so you want to draw something that looks like it has a 90-degree angle in it, and I don't like the way that looked. Let me do that again. Wow, it happened again. Let's go this way. Alright, So we know we need a 90-degree angle. So obviously you need to mark wherever you drew your angle that looks like a perfect corner of a paper, mark that as 90 degrees. Now, it's telling you which angle is the 90-degree angle. Remember, the middle letter is where your angle should be marked. So our 90-degree angle mark should be at T. So that is T, since that's the middle letter. All right, and then now we can go ahead and put our other measures here. So we have CA is 53, is the length of 53. So we have to figure out where we're going to put our C and our A. Our AT is 45, length of 45. So obviously CA is the longer one. So I'm going to put my C here. It's the longest, and then CT is the shortest. So if I put my C here and my A here, that'll give me a really long CA, which is 53. That'll give me a CT, which looks like it's supposed to be shorter, and an AT, which should be longer. So I'm just going to flip-flop my C and my A to where this will still be the long side. So you have to kind of like play with it a little bit. So if I flip it, gotta make sure it makes sense. So CA, so now I'm going to make sure it makes sense. So now that I flipped it, CA could be 53, that makes sense to be the longest. AT 45, so from here to here 45, and then CT 28, so that's the shortest one. So that makes sense now. So now I'm just going to go ahead and put those permanently on here. So CA 53, AT 45, and then CT 28. I'm not liking that 5, so I'm going to fix that really quick. Alright, so now we can go ahead and do what it asks. So it says to find the tangent of angle C. Now remember, when they just asked you straight up to find like the tangent, the cosine, the sine of an angle measure, it's very much like what we did up here, where we just, I did not mean to scribble on that, where we just, I did it again. Okay, here we go. So where we just found the fraction for those trig functions and we left it. So same thing here. So we are going to find the tangent of angle C. So angle C is up here for me. So now it doesn't matter where you put yours as long as you're trying, like you could have drew your triangle like this. It didn't really matter as long as you fit the requirements that is stated. So as long as you fit the requirements, the tangent, remember, is opposite over adjacent. So opposite of angle C is 45. And the adjacent, because if we look at this will be our hypotenuse. So that means our adjacent has to be this third side here. So that has to be our denominator, so 28. So 45 over 28, that should be our fraction. And does not simplify that I can think of. Nope. So we're just going to leave it just like that. So our final answer should be 45 to 28, or 45 out of 28 for the tangent of C. All right, moving right along to the last 3 problems. So this one's already drawn for us. Number 20 is already drawn. It wants us to determine the height of the flagpole. So right there, I should know where my variable is going to go. And we're going to round to the nearest foot. So remember to identify where your right angle will be in an application problem. We have to remember that any vertical, which would be a height, with a horizontal, like with the ground, will create a right angle. So we're going to identify our hypotenuse. Then remember, use your marked angle or your angle of focus to label the rest. So that's our opposite side. That leaves this one to be the adjacent. Notice if we're solving for x, we are looking for a side. So this is a side. And we know an angle and a side. We're looking for a side, we know an angle and a side. We're looking for a side, so it's one of these two. But we know one side and an angle, so we're going to use trig. We don't know two. We don't know 2 side lengths. We only know one side and an angle. So we know this side and we know an angle measure. So we're going to go ahead and set it up for trig by figuring out what we're going to use. We want to know the x side. We're going to use the 20 side. We have nothing on the hypotenuse. We don't want to care about it. So notice that O and A Hopefully you remember that to be tangent. So tangent of theta, which in this case we have an angle measure of 42, equals opposite over adjacent. So now if we set it up to cross multiply, hopefully you see we get x here. And then when we cross this other way, remember you put the 20 in front because you want to put the number in front that you're multiplying the trig function by. And now notice x is all the way by itself, so you could just put this in to see what our x is going to equal. This is round to nearest foot, so it's going to be approximately 18 feet. So x is approximately 18 feet, so the flagpole is approximately 18 feet tall. So in the next problem, you do have to draw the situation. So we have a 16-foot ladder, so that is how long the ladder is. Remember I mentioned in class that ladder problems are traditionally just messed up because people think that we have ladders that go straight up in the air. If you had a ladder that you were climbing up that was going straight up in the air and you were climbing that ladder, those of you who actually used a ladder before know that it is going to just topple over. So no one puts a ladder straight up in the air unless it's like screwed to a wall. So traditionally a ladder is going, if this is our wall, notice it says against a wall, rests against a wall, our ladder will be kicked out some so that we have some way to walk up the ladder without falling. So it does say it's a 16-foot ladder. It does say that the ladder is 6.5 feet away from the base of the building. So the distance from the bottom of the ladder to the base of the building is 6.5. So hopefully you see where your right angle mark comes into play. And we are looking for what angle, bless you, looking for the angle that the ladder makes with the wall. So notice our ladder meets the wall up here. So it is talking about this angle up here. So that is where our x goes. And once again, we are looking for an angle. So notice we're looking for an angle. We know two sides. So going back to our little decision guide, we're looking for an angle. So we know it's one of these. And we know two sides. So we're going to use inverse trig. So when we're using inverse trig, we have to still mark up our picture. So here is our angle of focus, but first let me identify my hypotenuse. Then our angle of focus will lead us to our opposite, and then we have our adjacent, the leftover one. But notice we are going to use, the sides of the hypotenuse because we have something on that. We have something on our opposite. We don't need anything off our adjacent, so we are going to use O and H. O and H. O and H. Once again, we're looking for an angle measure, so we're using inverse trig. But O and H is sine, so we're going to use inverse sine. O goes on top in sine. H goes in the denominator. And we get approximately, if we put that in the calculator, that the angle is should be approximately 23.97 if we round to 2 decimal places degrees. So 23.97 degrees. Alright, so remember inverse trig whenever you're looking for an angle measure and you know two sides. Now the last one, it's already drawn for us as well. So it says that we have a point, at a point 500 miles north. Remember north is straight up, y'all. So if we have a point that's 500 miles north of the ship. So here's our ship, 500 miles north, that means they're talking about this point here. But that gave us the distance between the boat and the point. The shoreline runs east and west. Well, that's obvious. East and west is horizontal. West of that point, so west of this point here, you'll find this lighthouse. The lighthouse, the navigator here on the boat notices the lighthouse at a 60-degree angle from the boat. How far is the ship from the lighthouse? So how far is the ship from the lighthouse? So we're looking for the distance from the ship to the lighthouse. So that is our x. So now notice what we have here. We are looking for a side of the triangle. We know one side length and the angle measure. We're looking for a side, so it's one of these first two. We know one side length and an angle measure. So therefore we're using trig. So we need to label the triangle so we know our right angle's here because that's where a horizontal meets a vertical. And that is our hypotenuse then. We are using our angle of focus of 60. Identify the opposite side and then the adjacent's the leftover. Remember, identify what we're using. We need to know our hypotenuse, so we have to use that, of course. We are looking for the x, if I could speak. And then our adjacent is the side that we know. So we don't need anything to do with this opposite side. So once again, we're dealing with H and A. So hopefully you recognize that as cosine. So the cosine of an angle measure is equal to the adjacent over the hypotenuse. And so we have cosine of our angle measure, which is 60, is equal to the adjacent, which is 500. See that there? And then over the hypotenuse, which is x in our case. So we are going to go ahead and set it up to cross multiply. So we're dividing by 1. And I'm going to go ahead and cross multiply. It doesn't matter which way you cross first, but notice here we're doing x times the cosine of 60 degrees. And then this way we're doing equals 500. So now I can divide both sides because x is not by itself yet. So we need to divide both sides by cosine of 60. And hopefully you see that x is equal to 1,000. I'm going to squeeze that in there. And we are dealing with miles as our units. Alright, so our x is 1,000 miles. So the distance between the boat and the lighthouse is 1,000 miles. Alright, so hopefully you guys see the use of the strategies and you kind of understand what to do where as far as when you're solving. But yeah, this is what you can expect as far as the different types of problems you will see on the test.